Everybody, how's it going? Today we're going to go through the hidden killers of site speed and how to fix them. There we go. Awesome. So I'm Brandon DePauw. I'm Director of Professional Services here at Miva. Some of you may know I come from a technical background doing development. So my 13 years of love of e-commerce here at Miva paired with the technical background and feeling very satisfied when we make performance improvements on websites lends me to be kind of excited about going through this content with you. It'll be a little bit more technical, but I hope you take some notes. So whether you're the person that implements this stuff or you take it to your technical team members that do it, I think we'll get some great tidbits out of this. All right, so today we're going to be talking about speed, right? And not just theoretical speed, but the technical debts that are quietly dragging down your site's performance, and that hurts your exposure in search results as well as your conversion rates. So I'm going to be walking through real-world issues that we regularly see in our performance audits, like the ProPerform audits that we do in professional services, and I'll be giving you the steps you need to go and address and fix those. So first off, we're going to dive into, speed is no longer just a technical luxury, so it's a primary conversion driver. So in 2026, mobile dominance and customer expectations, peak expectations, means that even a 100 millisecond delay can cost up to a 7% drop in conversion. And so by peak user expectations, right, like year over year, right now people are expecting more than ever when it comes from a highly performant site and their perceived experience on speed when that site is loading for them and they're interacting with it. So high performance is the ultimate tiebreaker, right, for organic search rankings and lower customer acquisition costs. So competitors may have content that Google feels is equally good as yours, right? And you want to have core web vitals that are ranking higher for that tiebreaker. So we're going to be talking about these are the big three. These are the big three metrics that Google and your customers care about. So first is largest contentful paint, so LPC. So largest contentful paint is the core web vital that measures how long it takes for the largest piece of content above the fold on the site to become visible to that user. So it's the primary metric used to judge the perceived speed and load speed. So basically the moment that the visitor feels like the page is useful. So LPC is usually, the LPC element is usually like the main hero or the largest and primary product visual. So your target on this one is going to be that 2.5 seconds, at or below 2.5 seconds. So lower is better. All right. The next one we got is interaction to next paint. So that's INP. So interaction to next paint measures your site's visual responsiveness. So while LPC measures how fast the page looks like it's loading, INP measures how fast the page reacts when a user actually does something like clicking add to cart or something like tapping a mobile menu on the site. So in this case, you want your target to be at or below 200 milliseconds for that measurement. So cumulative layout shift, these ones are always tongue twisters, which is why we say LPC, INP, and CLS. But CLS is a core web vital that measures visual stability. And so it tracks how much the elements on your page move around unexpectedly as that page is loading. So a high CLS score means a very shaky user experience, something where the buttons and the text might jump around suddenly as the page is loading, which leads to customers accidentally or users accidentally clicking the wrong elements on the page, which naturally leads to a really frustrating experience. I'm sure all of us have been on websites before where you're loading, you think it's loading, you go to click something and something shifts, and then suddenly you're on a different page somewhere you didn't intend to go, or something didn't even occur, like an action you expected to happen didn't occur. Like that's frustrating. You really got to avoid that one. That's one of the most apparent perceived issues. And so on this one, your target's going to be the at or below 0.1. So this one isn't measured in time, it's just a point value, numeric value. All right, so now we're going to talk about the hidden killers concept. So hidden killers don't throw obvious error messages. They're small, compound technical debts that inflate your time to interactive and your time to first byte metrics. How many of you, I think some of you were at the last session yesterday for Ultimate Checkout, raise your hand, did you get some tidbits out of that you felt like, hey, you're going to go take action to improve your checkout? All right, so great. So the promise out of this session is you're going to have specific actionable steps, again, that you can take and run with after this session that are going to make improvements on your perceived site speed without having to totally go and rebuild that site. All right, so let's get into killer number one. So killer number one, the back-end processing overhead and database queries that inflate time to first byte. Okay, so the problem here, using functions like read product code or read category code when unnecessary. So a common mistake in Miva template code is using code-based read functions like product read code or category read code when it's not strictly necessary to do so. This forces the database to look up text strings. The fix is simple in this case. You want to swap to the read product ID or read category ID type functions whenever available. So whenever that ID is available to use, that's going to be a more efficient function to use. So these are numeric-based ID lookups are way more performant. All right, so the loop penalty. The problem in here, so executing expensive lookups inside of for each loops. So if you run data load functions inside of for each loop unnecessarily, you're essentially multiplying your database queries that are happening in that loop. So you want to consolidate these calls by preloading custom field data through your Miva admin settings in one bulk query. So an example of this is like on the category list layout page, or search result list layout page, you have the ability to assign the custom fields that you want to load for that product data. You want to assign that there whenever possible to load that in one bulk call, as opposed to if your developer's going in and writing the code and putting all these individual load functions within that iteration loop, that's going to be less performant for your site. You also want to ensure that data load that isn't iteration specific is happening outside of those loops. So for example, you might have an iteration loop that's looping through products or some other list of items, attributes, things like that. If there's a piece of data that you need to use in that iteration template that is not specific to each iteration, so for products, not specific to each individual product, you want to load that data outside that for each loop. Otherwise, you're just redundantly calling and loading that over and over again in that iteration loop, causing unnecessary loads and calls. Problem number 2 on this, repeatedly calling standard load functions runs full database queries every time the page renders. So repeatedly calling standard load functions is a massive drain. You want to switch to the cached variants of those functions, like product load code cached or product load ID cached, if the ID is available, for example, like we just talked about, to serve data straight from memory. So this is a big one. There's a lot of old functionality from custom code and things like that written in the past, that if it's still using these old load functions that aren't the cached versions, it's a quick optimization to switch those over to the cached ones for a big gain.
You got an example of that, I guess, like we'd be using in our site for that?
Yeah, I mean, it's like you're going to load a record that you have to load a product, right? And you have a code for whatever reason. Maybe it's some type of array that is not loading from a full product record. You just have a list of codes. That is an example of if you're just running the load code function, it's just going to load all that product data. And then if you load it again later on the page, it's loading all of that query again. Versus the cached function, if it's already referenced it once, is going to reference that cached from memory. So instead of having to make those database queries over and over again, it's referencing the cache, and it's just a lot faster and more performant. And they're just simple switches to the other versions of those functions. All right. So next one on here we're going to talk about is the category tree tax, the category tree tax as we say it. So assigning resource-heavy items, in this example we use category tree as the example, to pages where they aren't displayed or aren't in use. So loading in an entire category tree, for example, on a page that doesn't use it is a massive drain. It's an unnecessary tax on the page's performance. So you want to audit your templates and make sure you unassign anything that's not being actively used. So in the Miva admin, there's the items tab under pages. That's one place where modules get assigned, for example. Category tree is just the example I'm using here of an item that can often be assigned on a page that it's not used. Sometimes that's because back in the day, it was used on that page for you, but you changed that page, and maybe you're not loading that in a sidebar anymore, but that didn't get unassigned when you removed that. You want to make sure that content's removed. So audit that, make sure the items that you're calling for various modules are actually being used on the page that they're being called on, so you're not unnecessarily loading that data when that page renders. All right, next problem is discontinued modules, legacy pixels, forgotten hard-coded scripts. So do some spring cleaning, right? Identify what modules are no longer used on your site. Clear out unused tracking scripts that are adding bloat to your store. So my suggestion on this one, if you cancel a service, stop using a module, anything like that, take the moment to do the cleanup at that time. We do lots of these audits. I've talked about ProPerform and things like that, and just very frequently, we'll identify scripts and we'll share it with the person that we're doing the audit for, and they're like, oh yeah, actually I canceled this 3 years ago, or 2 years ago, or 6 months ago, and all the while there's still been code sitting there running unnecessarily. We turned off the service, which stopped it from going to that third-party service or whatever it was, or the module, but that cleanup didn't happen. It's just adding bloat on the site. Oftentimes it could be a quick update to do that cleaning, and that compounds over time, right? Maybe 1 or 2, not as big of a deal, but as that compounds, that's when you start to get a meaningful negative impact. And then the reverse of that, once you get a clean up, especially if there's a lot of spring cleaning to do, you can get a pretty significant positive impact. All right. Killer number 2. So moving on to the front end, killer number 2 is about visual instability and rendering bloat. So the problem here, for example, 5+ images in a slider drains memory and main thread execution time. Additionally, using outdated libraries compounds that effect. So if you have more than 5 images or slides on a slider, you have a performance drain, right? Users rarely scroll past the first slide in those types of sliders, yet the browser still has to load all of that content within them. So you want to limit those sliders down to 3 or 5 slides and ditch the heavy libraries for clean, lean CSS and JavaScript sliders. In this case, if you're using, for example, like Page Builder and the sliders on there, great, you're already off to a great start. Now you're just in control of making sure you're managing the amount of slides you're putting in there and thinking about where's this slider showing. Obviously on mobile real estate, they're oftentimes not going past that first one. On your desktop real estate, depending on how many or how wide your slide content is, that's when you want to assess the desktop view, like how many they are seeing when they load it. If it's, they can see about 3, load 3. If it's more narrow and they can see 5, then great, go on 5. All right. So imagery. So we're going to talk about the sizing and format trap. So delivering high-resolution, desktop-sized images on mobile devices. Serving 2,000 pixel wide images on a 400 pixel container wastes a significant amount of bandwidth and increases memory usage and slows down your browser rendering time. So stop delivering desktop images for mobile. Use WebP format, for example, for massive compression gains, and implement responsive imagery whenever possible. And so what I mean by responsive imagery, for example, in page builder components, there's a place where you're going to upload your image for that component. You want to assess, there's usually a like additional, I think it's like additional images or additional settings, I forget what the text is called, but it expands it down. You're going to be able to upload not just a desktop, you're going to be able to get a tablet and a mobile image as well. And for a lot of those components for Page Builder, it's using the picture tag. And the picture tag then allows you to assess and potentially offer a unique style for those images based on the device. So for example, your desktop banner may have a certain background, a text placement that works really well for a desktop full view. But your mobile version of that may be just literally a different designed banner image where the image and the text is placed differently, so it's optimal for that device size. So it's not just an image at a smaller ratio in this exact same one, you can actually do different designs rendered at those different views. So that's really great. On other places on your site, and maybe you have content that's custom coded for some picture elements, in those cases too, your image tag, you can alternatively use source set sizes, and that'll allow you to do different image assets that are maybe the same image, just different resolutions, and then the browser can intelligently decide which one to deliver to that user that's going to be most optimal for performance and loading. Yeah. 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 So the question was like, hey, in the previous presentation, we had a lot of content, a lot of things going on the product page. So I think that that's okay. It's all about how you're compressing and rendering that content, right? So I imagine the strategy, what you'd want to optimally do is make sure that product carousel and those slider images are the right compression, the right size. When they're interacted with to load the full view, then it's going to render and load that full size. So the name of the game there is making sure all your assets and the various sizes they're displayed on page load, it's not just rendering and loading that full size asset at that time. It's rendering the one that's appropriate on the initial page load. So compression is really great. Again, like using WebP, you can have a lot of content if done well and optimized well and still be very performant. Where you get hit is when, again, they're not the right size, they're not compressed, they're not the right formats, they're not loaded properly. So we'll talk about in a second, like the ability to set priorities for eager load or lazy loading. That also tells the browser how to prioritize loading the content so the page loads most performantly. Kind of going right into the next one here, the problem, the lazy loading above the fold concept. This kind of goes into what I was just talking about. So you never want to use the loading lazy property on main hero image content. That's going to be above the fold content. Your primary LCP image or content should be using loading eager and fetch priority high. So this is informing the browser how to prioritize and handle loading different content on the page for the most optimal loading experience. So those are the types of strategies, like I was just saying, about the right optimized content, but then also informing the browser the right way and the priorities to load that content. When you dial that all in, you can achieve a good amount of content with really high performant load times. All right. So next we're going to talk about is image machine preload. So image machine is the Miva mechanism that handles loading imagery, like on the product page, for example. So image machines preload image settings can force images to load earlier than necessary in some cases. So that'll compete with more critical content and critical resources during the initial page load, which can negatively impact load sequencing. So in this case, the fix: disable the preload image setting in the product display layout image machine settings, and then retest to confirm the ideal result. So this isn't a blanket statement that like, just go turn it off for everybody, right? This is one of those things that can be an optimization depending on the scenario that you should test out and implement and then measure the effectiveness on it to decide if it's right for that page for you. So after disabling it, like I said, retest the product page, confirm that the primary image is still loading appropriately, and it hasn't had an overall load, it's improving the overall load prioritization on the page without introducing display issues. So, essentially, once you make that change, go and observe, like, are the images loading properly? Am I not seeing like CLS change? You can go run those core web vital scores against it again. You want to validate the impact of that change before you commit. In every case, this can be a little bit different. All right, and the next one on here is going to be a dynamic content fix for CLS. So content jumping as images and content loads. So this is that CLS I talked about at the beginning here. So to address CLS, you want to explicitly declare heights and widths on your images whenever possible. You want to use min height on your containers. So the goal here is to create a very rigid layout. So this allows the browser, as it's still rendering and loading that content in, to have an idea about the heights and widths necessary for certain elements on the page so that it's not dynamically changing that height and width once that content loads in. That creates a very rigid layout, so you avoid the significant CLS shifts that occur when that type of content gets loaded in, when the browser doesn't know what to expect. All right, so the excessive preload trap. So on this one, the problem is bulk preloading too many resources, such as like fonts, scripts, etc. It clogs the network pipeline. So preloading is great, but preloading but overdoing the preloading can create a traffic jam, right? So you want to prune the preload links down to just about 2 to 3 of your largest and most significant assets on the page. Next one is flash of invisible text, so FOIT. So flash of invisible text occurs while custom fonts load in sometimes. So the solution to this, leverage the font display swap property that prevents flash of invisible text events from occurring so that users can read that text immediately while the custom font is still loading in. So one call out is you want to be mindful on this, though, to pair the swapped font, like the font that you're setting up to initially load as the custom font loads in, and make sure it has the proper sizing applied to that font so you don't inadvertently cause a CLS issue. That can happen if the fonts are different sizes. So for example, say the custom font that you're loading in is a certain height, it's a little bit taller than the initial font you're putting in to load before the custom font does. What can occur is, while that bigger font loads in, then you cause CLS. So you want to make sure the properties and styling is set up on those fonts so they're going to be showing up at the same heights to avoid that CLS issue. And then an additional note on here, whenever possible, you should host your fonts locally rather than relying on external services like Google Fonts. That will reduce the number of DNS lookup delays. All right, now we're going to go over to killer number 3, which deals with scripts and caching. So the problem, loading heavy resources, including third-party resources globally across every page, even when they aren't used. So stop loading heavy resources on the pages globally. If a script is only used for the PDP, only load it on the PDP. Don't load it on every page of the site. This is a common one that I think comes up where resources get set up and implemented in the global header or wherever it is, and they're not assigned to specifically just for the pages that they need to be used on. Sometimes maybe originally there was a global element, and then it's been changed to only show on certain pages. Make sure that script is loaded just on the pages where it needs to be. Just adds a lot of global bloat if that's not done properly. All right, the next one, serving static assets like images and CSS directly from the server. So the store server origin increases geographical latency and server load. So you want to take a load off your origin server. Serve static assets like images and CSS through a CDN like Cloudflare, for example, to get that content closer to your users geographically. So they use what I call edge nodes, and that's going to get that content through that CDN closer to the person wherever they're at in the world, right? So that makes a big difference. It's really great. If you're not using it, take a look at that. All right, and then we have inefficient cache policies. So the problem here is missing long-term cache headers for static assets. So basically, returning users are forced to re-download unchanged files. So basically, if your static assets don't have long-term cache headers for them, you're punishing your return visitors by making them re-download content that hasn't changed over and over and over again. So configure the server to serve these long-term cache headers. This is just a huge win for perceived load time for any of those people that are going to be coming back on your site. All right, I think this is last but not least, we're going to get into Redis. So the problem is not using Redis full-page caching. So first, use Redis full-page caching. So it's an incredible feature for achieving sub 200 millisecond time to first byte scores. But you can accidentally either break it or not configure it properly. So a couple call-outs on that is you have to have defer creation of empty baskets turned on your store. Essentially, what that does is allows a thing called provisional baskets to exist. So when someone or bot or anything hits your site and it creates a basket session for that user, well, it'll create a provisional basket instead, which basically just says like, there's nothing unique about this person, right? This user is just hitting the site. They don't have something unique to their shopping cart yet or anything like that. So we're just serving them the same content that anybody else would see on the site. And that's where you load that Redis full page cache content. And so improper usage of basket write functions can inadvertently break the ability to serve Redis cache pages as much as they should. It basically converts those provisional baskets to, which would have otherwise gotten the Redis cache page to a non-provisional basket, and that's not going to get that Redis cache page. So for example, when this we often see occurs is someone has written custom code at some point that's storing some information about that basket or that user in the basket custom fields through a basket write function. And many times, at that point, if it's just initial generic customer that hasn't taken significant action yet, it's information that could instead be stored somewhere like a cookie on the client side instead of in the basket contents through a basket write function. Moving to that direction will allow you to maintain those provisional baskets up until they take an action like adding something to their cart or logging into their customer account. So more and more people get that Redis full page cache content. So another one is the parameters that are frequently added to URLs for tracking purposes, like the UTM parameters, for example, or many of you have email marketing services that when you do your email blast, you're going to tag on those tracking parameters in the URL. When somebody clicks a link from that email, it lands on the site, so you can track the performance of that marketing. And those are not functional parameters that are actually adding functionality to the site. So these parameters must be added to your store's cache settings and make sure they're excluded from the cache keys. So otherwise, your marketing blasts could go great, reach a bunch of people, big influx of customers and users hitting the site, but then they're not receiving Redis cache pages, so their site speed experience, the load times are not optimal. It's heavier on your server and your database as you have a large influx of customers coming. So not only is Redis really valuable for the customer, because they're getting an incredibly fast load time and a really, really good experience landing on the site, but it's great for your server when you're going to have a large influx of customers heading there at that time. Awesome. All right, great. So to wrap up on this, start properly optimizing your images. So size, format, device-specific image variations are awesome. That's, I feel like, very underutilized. The amount of time I've gone in and looked at people's page builder configurations that are not using those additional image options for tablet and mobile is a little bit surprising. I think it can look great. It makes your mobile look awesome if you're doing those assets designed for that viewport. So I think that's huge. Obviously, in addition to the other optimizations just for performance. Perform your spring cleaning on modules, global scripts. So go and identify what you're not using anymore and get ready and prepared to start removing that, whether you remove it or you get everything lined up so you can share with whoever the technical person is that's going to remove that content on your site so that they know like what you're not using so you can do that cleanup. Start taking action on all the other various technical improvements we talked about and covered. If some of these items, like I said, are either too technical for what you handle, or if you're just too busy managing everything else going on with the business, Professional Services is here to help. We make these kind of updates all the time. And as I mentioned, I think in my deck yesterday, if you're not already signed up for ProPerform or know about it, please come talk to one of us here at Miva. We'll get you the information you need to see if it's right for you, and then we can help you on the path to getting a more performance site. As many of these things we call out on here are just things we regularly see, and they're just optimal things to clean up. So you're reducing that bloat and having a faster, more performant site that's converting better and giving, just frankly, a better customer experience. Awesome. All right, thanks everybody. I don't know how I'm doing on time.